Hi guys. Things have been a little quiet about the power supply lately. I'll push this back so you can see it better. And that's because we ran into a bit of a snag. Now, I talked to some friends and they said I was an idiot for trying to weld a heatsink. And yeah, generally you're an idiot if you're trying to weld a heatsink because it's trying to get rid of the heat. And this is my first real attempt at TIGging aluminum. And at the end, it started to get okay, but that was because the whole thing, I think, was at about 500 degrees because we started at this end and we were working our way over. And I didn't know about preheating because I'm not a welder. So you can see that this is a fairly sizable heatsink. It's about 3/8 of an inch thick. And keeping heat in it is a challenge because it's going to try and get rid of that heat as soon as it can. This is the Mauser part number, by the way. It's a 12-inch heatsink by 4 and something. It's a good heatsink. It's a very decent heatsink. Not terribly expensive. And if you're looking for a decent heatsink, there you go. They don't sponsor me, by the way, but I find shopping for heatsinks somewhat difficult because I never quite know what to buy. But anyway, this is prep for TOW 3 packages, and I decided to stop here because, of course, it's aware to everyone except me that it was going to warp too much. Now, I knew it was going to warp. I didn't really care. I wanted to see what would happen because I'm perpetually curious about things of this nature. I've never done this before. And you can see, oh my god, it's horribly warped. Well, it's really not warped all that bad. That's a little bit of a warp. But it's kind of leaning over, and it's still usable, but I think we can do better. The reason for welding it was a desire to have intimate contact between the paddle, I'm calling this the paddle, and the mother heatsink. So the weld does give us intimate contact, but there's some warping here, and some of the weld size is consistent and the rest of it's kind of like all over the place, and it just in general does not have the kind of quality that I'm looking for in a product that I make. Mind you, this side was not preheated, and I was using 1/16 rod. So I was using rod that was completely inappropriate for this job, and it was burning back instantly. I was having a lot of trouble with this job. I've never done this before. This is the first time. Really, like, maybe I've never welded anything this thick before, so I don't know what I'm doing, and of course that's obvious to you critics out there, but I don't care. That's fine. You say whatever you want. You're not playing. You're not doing this stuff for real. So what we're going to do from here going forward is we have some L brackets and a new heatsink. We're going to attempt to save this one. So this is going to get ripped off, and then we're going to try to plane it and see if we can save this heatsink. Now that's not for a today thing. That's maybe many moons down the road. That's if even I want to even attempt it. I don't know if I even want to attempt it at this point. This may just be a swap meet item at this point. You know, $20 at the swap meet, get it out of my hair. I don't really care at this point. This is just one of those bumps in the road that you learn from as you go along, and it was a good learning experience. So we'll treat it as such, and we'll move on. So, like I said, the next steps will be to make a new tool to put holes into the L brackets, and I bought 3 of them. And if I mess one up, then I mess one up. But I bought 3 L brackets, 2x2. I really wanted U-channel for this project, but they don't sell U-channel in the dimensions that I want unless you buy a 6-foot stick of it. And well, I probably should have bought the 6-foot stick. It would have been cheaper at this point. But you know how we all think we can get away with doing things on the cheap, and then it ends up costing us more in the long run. You end up spending $1 to save a dime and chasing your ass doing it. Well, that's what I'm doing. I'm chasing my ass trying to save a dime here. But everything is a discovery, right? Everything has an adventure to it, and wasting money is this adventure. Now, one reason why I'd prefer there be no warps in any of this is because we're going to be mounting a circuit board to this. That's what these alignment pins are for. We have 2 keying pins here to key the board to the mating heatsink here. If it's warped, it's going to cause the circuit board to bend. And I'd really rather keep the circuit board flat to prevent stresses from building up in the circuit board. The other issue or potential issue we may have here is that circuit board is going to be over soldered with a bunch of solder and potentially strips of copper to help in current handling. So if there are mechanical stresses in this setup and we thermal cycle those products, then I'm not really sure what's going to happen. So potentially delamination of the copper from the circuit board, which would be bad. Solder cracking, which is, I know, probably unusual. But cold joints are not unusual. So there are some more mechanical reasons why we want things to be as stress relieved as possible. We're going to be using pin sockets for the legs of each transistor. So we want everything to be lined up and flat and as stress-free as possible for long service life. So if we try to build that into the product, then I think we should get fairly decent results instead of just winging it, which is what we're doing now. But hey, who knows? This is the first one of its kind, and potentially the last one of its kind. So we'll have to see how this goes. It's not even off the ground yet. It's still kind of in limbo at the moment. So that's enough rambling for now. And we'll have to see how the next heatsink goes.